Myself Dr. G. Nandini from Department of Mathematics, SNS College of Technology. So today we are going to see some problems on eigenvalues and eigenvectors. Eigenvalues and eigenvectors of a matrix play a vital role in all fields. So it is used in cryptography, and a major application of eigenvalue and eigenvector is in coding. So let us just see the problem based on eigenvalue and eigenvector. So find the eigenvalue and eigenvector of the matrix 2, 1, minus 1, 1, 1, minus 2, minus 1, minus 2, 1. So the given matrix is of order 3 cross 3. It has 3 rows and 3 columns. So we can find eigenvalues and eigenvector only for the square matrix. So what is the square matrix? It should have the same number of rows and same number of columns. Since it has 3 rows and 3 columns, we can find eigenvalue and eigenvector for this matrix. So what are the steps involved in finding eigenvalue, eigenvectors? So the first step we have to find the characteristic equation. Then second step we will find the eigenvalues, and third step we have the eigenvectors. So if this given matrix is of order 3 cross 3, we will have 3 eigenvalues. So the eigenvalues will be based on the order of the matrix. So for 3 cross 3 matrix, we will be having 3 eigenvalues. And corresponding to each eigenvalues, we will have one eigenvector. So we will be having 3 eigenvalues and 3 eigenvectors for this matrix, which is of order 3 cross 3. So the first step is to find the characteristic equation. The characteristic equation of 3 cross 3 matrix is given by lambda cube minus C1 lambda square plus C2 lambda minus C3 equal to 0. So this is the characteristic equation. We are going to find the value of the constant, unknown constant C1, C2, C3. C1 is got by adding the main diagonal elements. So what are the main diagonal elements? 2, 1, 1. 2 plus 1 plus 1 is 4. So we get the value of C1 as 4. C2 is the adjoint of the main diagonal. So we can get the adjoint of the diagonal element for this 2. You can get the adjoint by deleting this rows and column. So by deleting this rows and column, I will get 1 minus 2 minus 2 1 plus the next diagonal element is 1. Deleting the second row and second column, I will get 2 minus 1 minus 1 1. The next diagonal element is 1. Deleting the third row and third column, we can get 2 1 1 1. Then cross multiply. 1 into 1 minus 2 into minus 2 into minus 2 is plus 4. So 1 minus 4 is, we will get minus 3. Similarly, 2 minus 1, here we will get 1. Here 2 minus 1 is 1. So finally we will get it as minus 1. So the value of C2 we are getting is minus 1. We have one more constant, that is C3. The C3 is got by finding the determinant value of A. So we know the procedure to find the determinant A. I am going to expand this by first row. 2 into 1 minus 4. 2 into minus 4. Then the second element is minus 1. Minus 1 into 1 minus 2. The third element is minus 1 minus 2 plus 1. So calculating and getting C3 as minus 4. So we add 3 constants, and the 3 constant value we got as C1 is 4, C2 is minus 1, C3 is minus 4. So substitute these value here. So the eigen characteristic equation we will get as lambda cube minus C1 is 4. So 4 lambda square plus C2 is minus 1. So we will get minus lambda. C3 is minus 4. So minus 4 equal to 0. This is our characteristic equation. So the characteristic equation is lambda cube minus 4 lambda square minus lambda plus 4 equal to 0. So for this matrix, the first step we calculated the characteristic equation and we got the characteristic equation.